In this video we are going to look at quadratic functions and models. Quadratic models or quadratic graphs look something like this or something like this. In other words, they represent a parabola. That's the name of this shape. This shape here, if it's smiling at you, it means it's concave upwards, and if it's like this, if it's not happy, then it's concave downwards, if it looks like this, of course, there's a vertex, right? A vertex is the kind of turning point of the graph down at the bottom, so it's a minimum, right? So it's a minimum if it's concave up. It's a minimum if it's concave up. If it's like this, of course, the vertex, this point here, is the maximum. Okay? And what decides whether it's concave up or concave down is the value of a. Now, a is the number before the x squared. Remember, your quadratic function is going to be ax squared plus bx plus c. The a, the number before the x squared, if that is positive, then you're happy. If it's negative, then you're unhappy. Now, if you look further down, we'll see that we have some functions down here, y equals x squared, and we've got the corresponding vertex next to these. Now, you can find these vertices, these minimums or maximums, just by graphing the function in your calculator or on GeoGebra and just reading off the coordinates of the vertex. Now, what we can also do is expand each of these. So, for example, if I take this one way down here, the y equals x minus 3 squared, if we expand x minus 3 squared, we will get x squared minus 6x plus 9. Now, the significance of that is that if we think of x squared minus 6x plus 9, the a, the b, and the c are 1, negative 6, and 9. Well, that might not seem like any big deal, but if we then calculate whatever negative b over 2a is in this column to its right, we'll get 3. And that happens to be the same value, that 3 happens to be the same value as the x-coordinate of the vertex. And if we wanted to find the y-coordinate, right, so this might be the x-coordinate of the vertex. If we want to know the y-coordinate, we can then take that 3 and put it back into this equation here. So the 3 goes back in here, so it's going to be 3 minus 3 all squared, which would be equal to 0. And that gives us 3, 0 as the coordinates of the vertex. So if your equation was in this form instead of in this form, then you could take your a, b, and c, and you'd be able to find the coordinates of the vertex. Okay, so I'm going to take off the other things that are hidden here, so you can see the a, b, and c, and complete the rest of this table. Okay, now on the second page, we have a similar kind of bunch of things. You can find the coordinates of the vertex in this column here by just graphing on your calculators. And then the rest of it, you can expand the brackets. For example, in here, if we expanded all of this, we'd have x squared minus 2x plus 1 plus 3. And when you simplify that, you'll get a equals 1, b equals negative 2, and c equals 4. Calculate, you put your negative 2 in place of b, then you've got 2a on the bottom, we get an x-coordinate of 1. And lo and behold, your 1 is the x-coordinate of the vertex. And that 3 we can get by putting 1 into this equation here. 1 minus 1 squared plus 3 gives you 3. Now, that enables us to answer questions like this. In example 1, can we give the vertex of this equation here of 2 times x minus 3 squared plus 7? Well, just pick off the 3 and the 7, and that gives us our vertex. Our vertex should be at 3, 7. And then if you look at example 2, you can pick off the 5 here and the 2. Now, it has to be the reverse or the opposite sign from positive 5, so it has to be a negative 5, 2, like that. And then the vertex of this thing, we can ignore the negative 3. The negative 3 doesn't matter. What matters are the 2 and the negative 4. So in this example here, we have 2, negative 4. In example 4, further down this page, we have to use this expression here to get the x-coordinate of the vertex. So the x-coordinate of the vertex of this thing, we use a equals 2, b equals negative 12, and c equals 25. If we do b over 2a, that's going to give us a negative 12 over 2 times a, which is 2. But remember, we've still got that negative before it. The negative and the negative there make a positive. So it's going to be positive 12 over 4. And if we simplify that, we should get 3. So the x-coordinate is 3. We then take that 3, we put it in place of the x over here. So it's 2 times 3 squared minus 12 times 3 plus 25. And if we do that, what we should get is something that looks like this. And if you simplify that, it's 18 minus 36 plus 25. And then if you take the extra step to calculate that value, it should be 7. And that means that the vertex is at 3, 7. The x-coordinate is 3, the y-coordinate is 7. You can do a similar thing in example 5 and in example 6. In this example here, your a is 1 and your b is 10. So when you do that calculation, you should get negative 5. Take your negative 5, put it in place of the x, and what we should end up with is this. I'll just adjust that slightly so you can see it all. We should end up with a y-coordinate of 2. So the vertex then is at negative 5, 2. In example 6, again take your a equal to negative 3, your b equal to 12, put them into this formula. What we should get when you do that is 2, and then take your value of 2, put it in place of the x here and here, and what you should get as a result, and again I have to adjust this for you a little bit, what you should get as a result is negative 4. So the vertex in this example is going to be 2, negative 4. Now we can use all that to write a quadratic in vertex form. So if you've got something that looks like this kind of thing here, we can rewrite that in the other form, this form here, which is a vertex. The vertex here is h, k. And it's easy to find h and k from this now because we know how to get the x-coordinate of the vertex. the x-coordinate, the vertex, we get by doing negative b over 2a. So we know a is 1, b is 10. We can plug them in here, and what we get if we do that is negative 5. You can then take your negative 5, put it back in here and here. When you do that, you should get negative 16. So all in all, this x squared plus 10x plus 9 is equal to x plus 5 squared minus 16. If you like, you can think of this as being x minus negative 5. And since it's x minus negative 5, it's going to be plus 5. We're taking that negative 5, and that's our h value here. It's x minus the negative 5. And then a negative 16 is just what k is equal to. Okay. In example 8, it's exactly the same kind of thing. You'll take your a equal to 1, b equal to negative 5. You'll put them into the formula, negative b over 2a. You get 2.5. And then you have to use your calculator here probably. You take your 2.5, square it, which gives you 6.25, minus 5 times 2.5, that's minus 12.5, minus 7. What we should end up with, if we do that, is negative 13.25 rather. So your y is equal to x minus 2.5 squared minus 13.25. And then the last problem here, example 9. This time you've got an a equal to 2 and a b equal to 3. You'll put those into those formula, negative b over 2a, and you'll get negative 0.75. Notice, please, that when you're dividing this, the 2a makes 4. So on the bottom here we have to divide by 4. Please don't make the mistake of doing on your calculator negative 3 divided by 2 and then multiplying by 2. That would be a bad thing to do because we have to divide by this whole thing here, the whole of the bottom. So put everything in the bottom in brackets. That's a general rule for doing calculations that involve fractions on your calculator. So you get an x-coordinate of negative 0.75. Take that, plug it back in place of x here, and what we should get then for k is negative 6.125. Okay, so the expression in vertex form, so this expression here in vertex form is going to be written as y equals 2 times x plus 0.75 squared minus 6.125. Just let's take a few moments to look at this again. The negative 0.75 becomes positive over here. The negative 6.125 stays as negative 6.125 because k just stays the same. And because there's a 2 here, because this is our a, there has to be a 2 here. If you imagine expanding these brackets, the x plus 0.75 squared, we would end up with an x squared term. That x squared would have to be multiplied by 2 to give us 2x squared. So the number, just remember that the number here must be the same as a here.